Hello everyone, myself Banu Prasadam from 3rd Sem CSC. Today let us discuss or try to understand the introduction to PSpice concepts. So before that, let us see what is PSpice. So PSpice stands for Personal Simulation Program with Integrated Circuit Emphasis. So it is a simulation software tool which is used for analog, digital and mixed signal circuits. And PSpice is like a computer program that helps people design and test electronic circuits, which are like parts for electricity. So it tests the electronic circuits, which are parts for electricity. Okay, then this presentation aims to explain key PSpice concepts with practical examples to enhance our understanding of circuit design and analysis. Coming to the introduction, the abbreviation of SPICE is Simulation Program with Integrated Circuit Emphasis. Then PSpice is a version of SPICE developed in 1970 at University of California, Berkeley. Enhances original SPICE capabilities. Widely used for analog and mixed signal circuit analysis. Features user-friendly interface essential in both educational and professional settings. Simulate circuits, modeling behavior and calculating electrical characteristics. Allows for graphical output through data transfer to the program. So what is PSpice? Introduction to PSpice is nothing but the simulation program is instrumental in testing and refining circuit designs that involve analog or mixed analog devices before the actual hardware implementation on PCB, nothing but printed circuit board. PSpice excels at modeling the behavior of these circuits and calculating their electrical characteristics. It goes behind analysis, providing graphical outputs by seamlessly transferring data from the probe program, enhancing the visualization of simulation result. Overall, PSpice stands a valuable tool for engineers, designers in ensuring the efficiency and reliability of electronic circuits. Let us see the educational use of PSpice. PSpice simplifies circuit design and analysis, allows circuit simulation saving the cost and time without physical parts, enables students to explore and learn from various circuit outcomes. PSpice is valuable for teaching both analog and digital electronics. Students can simulate the behavior of analog circuits such as amplifier and filters, as well as the digital circuits like logic gates and flip-flops. Students can learn about the characteristics of various semiconductor devices such as diode, transistors, and operation amplifiers by using PSpice to simulate their behavior. This hands-on experience enhances the understanding of device models and specifications. Moreover, PSpice simulation empowers students to virtually troubleshoot the circuit. This practical approach allows them to identify and rectify the issues within simulated circuits. Overall, the PSpice emerges as an individual tool in the education landscape in bridging the gap between the theoretical knowledge and practical application in the field of electronics. So some of the basic components in PSpice are resistors, capacitors, inductors. Resistors are fundamental components used to restrict current flow and create specific voltage drops within a circuit. Capacitors are used to store and release electrical energy and are commonly used to filter noise or create time delays in circuit. Inductors are used to store the energy in magnetic field and are essential in converting or transferring energy within circuits. So some of the types of circuits are analog and digital. So analog circuits process is a continuous signal providing a smooth output based on the variations of input signal. They are crucial in application like audio amplifiers and power supplies. Coming to the digital circuit operate with discrete voltage levels representing binary information. They are fundamental in building computer systems, logic gates, and microcontrollers. Like these are the basic circuits in PSpice. Moving on, let us see the semiconductor devices in PSpice. Some of them are diodes, transistors, bipolar junction transistors, field effect transistors. Diodes are nothing but are the key electronic components that conduct current primarily in one direction, crucial in rectification and signal processing. They are the key electronic components that conduct current primarily, and they are very crucial in rectification and signal processing. Coming to the transistors are used for amplification and switching signals in electronic devices, making them fundamental to modern circuit design. Bipolar junction transistor (BJT). PSpice supports models for both NPN and PNP bipolar junctions. Transistors. These models include parameters such as beta, which is current gain, and other transistor characteristics. Field effect transistors. PSpice includes models of both N channel and P channel field effect transistors. These models capture the transistor behavior, including parameters like transconductance and threshold voltage. Let us see some of the simulation modes in PSpice, such as AC sweep analysis, transient analysis, DC sweep analysis. So, coming to the AC sweep analysis, it is used to analyze how the circuit responds to varying frequency by providing valuable insights into its frequency dependent behavior. Transient analysis is nothing but which enables the study of a circuit behavior over time, crucial for understanding dynamic responses to input signals or disturbances. DC sweep analysis allows the examination of the circuit responses to a varying DC input, useful for determining the performance under different biasing conditions. Coming to the applications of PSpice in circuit design, here are some of them like filter design, power electronics, signal integrity analysis, and design phase, optimization phase, verification phase. Coming to the filter design, PSpice aids in designing and optimizing filters, ensures efficient signal processing in communication and electronic systems. Engineers use, like in power electronics, engineers use PSpice for designing and testing power electronic circuits such as converters and inverters to ensure optimal performances and efficiency. Then coming to the signal integrity enables the analysis of signal integrity issues in high speed digital systems, ensuring reliable and accurate data transmission. Going to some more applications of PSpice in circuit designs are digital design phase, optimization phase, verification phase. Coming to the design phase, this facilitates an initial circuit design, providing insights into the component selection, performance evaluation, and the safety checks. Optimization phase. During this phase, PSpice is used to fine-tune the circuit's parameter for improved efficiency and performances. Coming to the verification phase, PSpice allows engineers to verify the circuit functionalities and the performance before the prototyping. That's it. Some of the challenges and solutions in PSpice simulations are the challenges are seen in the convergence. And the engineers encounters convergence problem when simulating complex circuits, which requires a careful parameter adjustment and modeling techniques. Noise analysis, handling noise analysis is sensitive electronic circuit can be challenging, but requires advanced simulation setups and signal processing techniques. Coming to the simulation time, simulating a large circuits is very challenging, but it requires significant time, necessity, efficient use of computational resources and solver configuration. Some of the PSpice integration schematic softwares are OrCAD, Xylene ISC, NI Multistim, ModelSim, LT Spice, PSpice. So here are some of the real world applications of PSpice like electronic product development and circuit analysis in research. In electronic product development, the PSpice plays a vital role in development and testing of electronic products, which ensures their reliability and performances. Coming to the circuit analysis in research, it plays a crucial role to the researchers to analyze the model complex circuit for advanced technologies and innovation. Some of the future trends in PSpice and circuit simulations are AI integration, IoT connectivity, cloud-based simulations. Future developments may involve AI-driven optimization and predictive capabilities for circuit performance. IoT connectivity, which enhances tools for simulation IoT devices, circuits, and understanding their interaction within broader network. Cloud-based simulation, potential shifts towards cloud-based simulation platforms for scalability and collaborative design work. So this is the outlook of PSpice schematics. So let us see some of the components of PSpice like file, edit, draw, navigate, view, options, analysis, tools, markers, window, help. Here are some of the standard schematics like create a library, which is used to create a library. Open library is used to open an existing file. Save library saves the current stimulus library. Print prints the active window. Cut removes the selected object and places it on the clipboard. Copy copies the selected object and places in the clipboard. Paste the contents of the clipboard to at the place where the cursor is pointed. Undo undoes, redo redos, and this is a redraw, which is used to redraw the wire line. This is zoom in to the particular point, zoom out from the particular point, zoom for up, zoom in or zoom out for zoom in for the particular area, and this is used to zoom to the fit the page. Coming to the voltage marker, voltage level markers are used for the voltage level markers on the schematic page, and this is current into pin marker. These are also used to mark the current point in the schematic region. This is in this page, and this is used for simulating new simulation. So in PSpice, some of the steps are like in step one, we need to place the circuit components on the screen, and then we have to set the values for the attributes of each. We have to set the values of attributes to the each, and then set up the type of analysis we have to do. We have to set up the analysis which we have to do, and at last we have to run the simulation which launches the probe. Let us see how to prepare a circuit for simulation. First of all, you have to click on the start menu and select all program, electric apps, ORCAD family. Then select the PSpice designer. So like this. Select the PSpice designer. Then go to the you will get a screen like this. Select the file option and take new workspace. Give new workshop name. Give the name of your new workshop. As I said it before, we have to create a library, so we're gonna create it, and then to get a new part, click on draw, get a new point. uh, then after getting the new part, this window will open up. Enter the part name or the number, like if you want to get an AND gate, enter 7408. The AND gate will be visible here. Then you click on place and close. The AND gate will be on the schematic page. Next, need to place a digi-clock on the schematic page. So to place a digi-clock on the schematic page, you need to open the get new part window and then type the part name as STM, which will be visible like this. Then click on place and close. This digi-clock will be on the schematic page. What is the need of digi-clock? Digi-clock is used to in PSpice to analyze and understand the timing characteristic of digital circuits, which ensures the proper synchronization. It allows testing and verifying the functionalities of sequential circuits such as flip-flops, counters, which are common components in digital clocks. assists in identifying designs, limits, timing margins, and potential issues. It enables engineer to analyze the frequency, domain, characteristics, and circuit essential for application, like digital signal processing. Simulation helps estimate and analyze power consumption, especially in relation to clock frequency. Now, by seeing these points, we get to know that how important digiclock is. Digiclock in PSpice for various aspects of digital circuits. It is very important in various aspects of digital circuits such as design, analysis, and optimization. Moving on, now let us see on time or off time. On time defines the duration of I signal crucial for synchronization digital operations. Ensures the compatibility with component requiring specific plus widths. Enables precise control over signal duty cycles. Facilitates testing of circuit responses to varied signal duration. Supports simulation of real world scenario when signal timing is critical. Coming to the off time, determines the low signal duration essential for timing and synchronization, adjusts the ideal period for energy saving and power sensitive application, allows for the simulation of various duty cycles to optimize performance critical for testing circuits under condition of intermediate signal absence, helps in mimicking real world signal with specific off time characteristics. So in PSpice, on time and off time typically refers to the duration a circuit element or a signal spends in an active on state and an inactive off state respectively. For example, in a plus waveform, the on time is the duration during which the signal is high and the off time is the duration during which the signal is low. These parameters are crucial in analyzing and simulating electronic circuits, which helps us to understand how the components behave over time. When using PSpice or other simulation tools, you can set these on time and off time values in the properties of the plus or square waveforms to simulate different pulse shape and duration. When simulating circuit in PSpice, you may specify the on or off time for your switching devices as part of the simulation settings in the component properties. These properties, the meaning of this line is you can change the on time or off time in the simulation settings. That's it. These parameters are essential for accurately modeling and analyzing the behavior of switching devices in application like power converters, motor drivers, and other systems. Uh, that's it. So on time and off time plays a very important role in understanding how the components behave over time. Let us see about voltage markers. So a voltage marker is an electronic circuit like those used in tools such as PSpice, which is a visual representation or indicator placed on a schematic diagram to show the voltage at specific point. This is used to show the voltage at specific point in the circuit, which helps us to understand and analyze the voltage level at various nodes of our components by facilitating the accurate simulation and troubleshooting of the circuit. So connect all the components to complete the circuit diagram, and if we want to display the voltage at a specific node of the circuit diagram, we can do this by placing a voltage marker at that node on the top of the schematic window. This is a schematic window. There the voltage marker will be present here. You can select it, click on the voltage level marker button as shown in the figure below. To use the voltage marker in PSpice, place the marker at the desired node in your schematic. During simulation, the voltage marker will display the instantaneous voltage at the node. Now why do we need voltage marker? The need of voltage marker is because voltage marker plays a crucial role in circuit analysis and debugging by identifying the issues through the voltage observation. Using the voltage marker especially helps us to monitor specific voltage at critical nodes or across key components in our circuit. It allows us to visualize and analyze the behavior of the circuit during simulation and gain insights into the performances. Enables optimization of circuit performance by analyzing voltage level. By seeing these points, we can come to a conclusion that saying that the voltage marker helps us to identify and address any issue on design challenge. Next component need to see is label. So if we want to label a particular line, I mean particular wire or a particular place, we need to double click on the wire, and in the window that appears the window appears like this, and then type the name of the wire and label it. So what is the use of labels? Label helps us to identify a specific node. We can give a specific name to a specific node, and which becomes easy to identify that particular node. And label acts as a reference in simulation settings, allowing you to specify the nodes where measurements, voltage markers, or other analysis will be performed. Labels aid in connecting various components in circuit by providing a common reference point for multiple elements. Label makes it easier to modify and update circuit connections or nodes without changing node numbers, contributing to more efficient design process. Label enhances the readability of a circuit diagram by replacing node number with user-defined names, making it easier to understand and troubleshoot. So coming to a conclusion that why do we label is using label ensures us like organizing the data in readable manner with an efficiency in designing the process. So we can organize the data in a readable manner with efficiency designing process. So let us see the input attributes. Checking out the input attributes are the next step followed with giving the labels. The next step is to set the attributes of the input digital supply. To set the input of digital supply, we need to double click on the digiclock 1 supply we connected in the circuit previously, and set the input command of the digital input system as shown below. We have to give the input command for the digiclock 1 as this, and the commands in the attributes window represents the value of the input at the corresponding time. This represents the input of the value of input value at the corresponding time in the command before the space. The command 1 equals 0 seconds. In this, the command 1 equals 0 seconds. 0 shows that at time 0, the value of the input is 0. And the command 2 equals to 1 second. 1 shows that the value update to 1 at time 1 second. Similarly is the case with the command 3, 2 seconds is 0, where at 2 seconds the value of the input will be 0. Next, we need to set the attributes of the input digital supply. The attributes of input digital supply can be set by double clicking on the second digiclock, which is used as the supply to the source B connected to the circuit, and set the input command as shown below. Next, coming to the simulation setup. After giving the attributes, we need to simulate the particular circuit. So the next step is to adjust the properties of the simulation in order to produce a graph of voltage at the marker. To produce the graph at the voltage of the marker, we have to click on the analysis and then click on the setup as shown in this figure. Click on the analysis and then click on the setup. Then a window will appear. Click on the transient block. Click on this transient block. After clicking the setup, the window will appear. Click on the transient block. Then adjust the properties of the window according to the requirements. Like we have to give the values according to our requirements and click on OK. Then go to the analysis and give simulate. The final time of the response is 2 seconds, and there is an output after this slide. In that, the final response is 2 seconds because we gonna set we set your time, the final time as 2 seconds. So coming to the simulation part, click on the analysis of the top bar of the schematic window and then click on the simulate. After, I mean, we see here we are setting the time, final time as 2 seconds. So the response for the output in the coming slide is taken as 2 seconds. So if you want, you can change this 2 seconds to 10 seconds or 5 seconds. Um, after transiting, transient the, I mean, after completing this step, going to the next step, you have to go to the analysis and click on simulate. Now let us see an example on how PSpice works. Let us take half adder as an example. So to get an half adder, we require an XOR gate and an AND gate. So to get an XOR gate and NOR gate, I mean AND gate in and schematic on a schematic page, we need to go to the get new part window and we have to type 7486, which is XOR gate number, and we have to type 7408, which is an AND gate number. And then after selecting both, we need a digi clock for supply. So we take two digi clocks and one XOR gate and one NAND gate. Now after selecting the digital supply from the list, then the components are placed on the schematic window. So these are placed on the schematic window. Then we need to draw the wire. We have to select the wire. I mean, we have to select the wire icon and draw the wire from digi clock 1 and digi clock 2. After drawing the wire, the voltage marker, we have to use the voltage markers and the label to give the label diagram of the half adder. After using the voltage marker and labeling the wire, we get the output, or the circuit is as shown in this figure. The half adder will be seen like this. Next, after completion of the drawing of the half adder, we have to simulate. We have to undergo the simulation. After undergoing the simulation, the output of the half adder is as following. This is the schematic window, which appears showing the voltage at the output wire and the input source. So output of half adder is in accordance with the theoretical analysis. Then coming to the conclusion, the key points covered in the explanation of PSpice includes: PSpice is a powerful simulation software widely used for analyzing and testing electronic circuits. We got to know that the PSpice is a powerful simulation software and which is used for analyzing and the testing the electronic circuit. Next, we got to know that it provides a comprehensive library of electronic components, allowing users to model real-world device accurately. Then it offers various analysis tools including transient analysis, AC analysis, DC analysis, and Monte Carlo simulation, providing valuable insights into circuit performances. User can perform parameter sweeps to analyze the impact of changing components values on circuit behavior. Voltage marker helps visualize and analyze voltage waveforms at specific points in the circuit, aiding in debugging and optimizing process. Understanding on and off time is crucial for accurately modeling switching devices in applications like PWM control or switching power supplies. Thus, PSpice is more powerful and widely used simulation software for electronic circuits that offers a comprehensive set of tools for designing, analyzing, and simulating complex electrical systems through its graphical user interface. User can create circuit schematics and define components properties and set up simulation parameters. So this comes to an end, and we got to know that PSpice is a widely used simulation software for electronic circuits, which helps us to analyze design circuits before building them physically. Before building physically, we can check them once in this software. And in conclusion, PSpice is a powerful tool for electronic circuit simulation, which aids all the students and engineers to know the to validate the circuit efficiently. So at last, I want to thank ma'am for giving this opportunity, and thank you for your attention. And may your circuits always be optimized and error free.